Hey guys, welcome to Aloha Finances. This website's going to be focused on portfolio theory and be based in the programming language R. R was difficult for me to pick up, so I'm hoping this video can help some people pick up the language a bit faster. The first video will focus on importing data from the Pharma-French website. Then once we've imported the industry data, we'll begin to manipulate the data set. And finally, we'll calculate some basic summary statistics for the 47 industries, the equally weighted portfolio, and the market portfolio. Hope you enjoy. All right, let's get started. The first thing we need to do is download the industry data from my website at alohafinances.com. You can see it right here in a zipped folder. You can also go to the Pharma-French industry data website, but you'll have to also upload the risk-free rate and the excess return on the market. So I've done a bit of a shortcut for you. And when you're saving this file, make sure it's saved as a CSV. And then once you have that saved down, we can get started in R. Okay, we've made it to R and we're ready to import the data. The first thing we need to do is set the working directory using the setwd. Parentheses, quotations, and go ahead and copy the directory of where you saved the file. And the only thing here is you got to remember to add an additional backslash wherever you see one so the directory is set correctly. Once we've set the working directory, the next thing we need to do is actually import the data and assign it a variable. So I'm going to call it data read.csv. quotation marks, and then I know my file is called 47 indus-day, and then you just need to add an additional CSV. Let's import that, and you can see that it's uploaded 50 variables and over 12,000 observations. So I think it's useful sometimes to check the data that you've imported. So we can do that using head, and then we'll put in data. And you can see that all of our industries have been uploaded along with the risk-free rate and the excess return on the market. So we've done it correctly here. Okay, our next step is to define the sample size given the large data set we've imported. So the first step is to define the width of the matrix using the length function, but we're going to assign a variable to it using the NIND, just referring to the number of industries. And then we use length, data, 1. So here is simple subsetting. Everything before the comma refers to rows and everything after the comma refers to columns. And this is key to our analysis, so it's important to grasp this as the code gets more complex. And then we're going to subtract 3 to exclude dates, excess return on the market, and the risk-free rate columns. And then we'll check that answer, and we get 47. Next, we want to combine the columns of our dates, industry returns, and total market return vectors into one matrix. We're also going to assign a variable to this, RETS, for returns. And we'll use the cbind function to create the matrix. And we'll start with the date vector. And again, the subsetting here means all rows and just the first column. And we'll combine that with the 47 industry datas. And the subsetting here means it's spanning from column 2 to the number of industries we have, plus 1 because the first column is the dates column. So we need to account for that. And then we're going to subtract the risk-free rate, which is found in the number of industries plus 3. It's the 50th column in our data set. And then we're also going to combine that with our excess returns on the total market, which can be found in the data set in column 49, which is denoted as 9 plus 2. And then we should check that we've combined this matrix correctly using the head function and RETS. Okay, you can see you have the excess return on the markets, the 47 industries, as well as the date. So we've done this correctly. Now that we've created a matrix with daily excess return data for the 47 industries, the total market return, and corresponding dates, we want to define the sample period. So we're going to start with assigning variables to the beginning of the period using YBEG, let's say 2009. and Y end for the end of the period in, let's say, 2013. Assign those variables. Now, if you look at the dates through the data, column 1 subsetting, just referring to the first column, you can see that all of these dates within the console are multiples of 10,000. So knowing this, we can use an AND function to define the returns between this period. So we'll start with returns bracket, immediate common, and then we're only working on the left side of the comma because we only want to refer to the rows. And then with returns, bracket, comma 1. So with only the rows, we want to refer to the first column is going to be greater than Y beginning times 10,000. And returns, comma 1, again, only referring to the first column within all of the rows is less than YN plus 1 to include 2013 times 10,000. And let's check our result. And you can see everything's been populated towards the top of the observation, so it looks like it's correct. The last step in this video is to calculate annualized summary statistics for the 47 industries in equally weighted portfolio in the market portfolio. So we'll start by defining a variable DPY for 252 just to represent the number of trading days per year for simplicity reasons. And then we'll also start to calculate the mean and the standard deviation for the 47 industries. We'll use the apply function. So the apply function literally applies a function to a vector or matrix. The first term, so first let's define a variable mu_m to represent the mean. Apply. The first term in the apply function refers to the matrix, so returns, comma, spanning from 2 to number of industries plus 1. And then the second term can either be a 1 or a 2, where 1 refers to the rows being applied, the function is applied to, or 2 means the columns. And in this instance, we need columns. And then the third is the function actually being applied, which is mean. And then we want to multiply this by the number of trading days per year to get an annualized number. And let's check what we get here. And you can see all of the returns have been annualized for the 47 industries. That's great. To calculate the standard deviation of the 47 industries, we're again using the apply function, but just with two small differences. So we start by assigning a variable, and then we can copy this same function, but now the function being applied to the matrix is standard deviation, and we need to multiply it by the square root of n, or the number of trading days per year. Now let's make sure this populates. And you can see the annualized standard deviation of the 47 industries has been populated. For simplicity purposes, I've gone on and coded the annualized mean and standard deviation of the equally weighted portfolio as well as the total market portfolio. The answers are provided down in this console if you want to check it out. This is the end of this video, but in the next video, we'll begin forming the efficient frontier. So I hope to see you there.